Okay, so thank you again for spending your Sunday here. The specialists have been here until now. And as you may heard already, we do launch a new triple quadruple instrument, Q-Trap Ready 55 Plus. And in next 10 or 20 minutes, I try to show you some real data, what we got with this instrument, and show you why we do believe this system will help you for your routine contaminant testing. Okay. So without going to detail on this technical detail on this instrument, I just want to highlight the two major performance enhancement on this instrument. The first one is that you have a high speed on positive negative switching. And the second one is that you have extended linear dynamic range. And if you look at positive negative switching, so the classic 55, the switching time is 50 milliseconds. With this new instrument, you have a switching speed can go up to 5 milliseconds. I will show you some data with mycotoxin analyze, and you will see why it's so important for mycotoxin analyze. So if you look at the switching time, this is a very performance in generic. If you look at if you have 50 millisecond switching time for one cycle, you need to have at least 100 milliseconds, means positive to negative, then back to positive. If you have 5 milliseconds, of course, will be 10 milliseconds. You will save 90% of the time for the switching. And most important, of course, is that you need to make sure with this fast switching time, the performance of your peak, both on intensity and also as a signal to noise, will not change. You have the same performance with high speed. So then we decided to test this performance on mycotoxin analyze. Why is that? So first of all, it's clear mycotoxin is toxic, and it contaminates both food and feed, and it's a big danger for consumer and also for food movement, food supply chain. And if you look at the mycotoxins, and many classes are regulated in different countries in the world. Okay, so there are different levels. Of course, European have a more lower level compared to other areas. So, but some, let's say, most important classes are regulated. But recently, if you look at newly researched, you will see a lot of new mycotoxins. So we call that emerging mycotoxin. You are not know before, and also sometimes they're called masked mycotoxin. What is that? That means the mycotoxin is very difficult to detect. It's not easy to detect them. So with this, so you will see that the panel of mycotoxin you need to test is extended rapidly. So some years ago, people are testing maybe 50 mycotoxin. Now they are talking about 1,000. So a lot of emerging mycotoxins there. And another thing is, of course, unlike other contaminant classes, mycotoxins nearly half, 40% you need to run in negative models. So that means you cannot save some injection that you need to run in negative models. And if you look at all the routine test lab, now most of them are using 2 injections to cover entire panel, positive one, negative one. And of course, for them, it's quite urgent to get some method that can save time. So if you look at the publication, there are even some publications just to short LC method, LC runtime, so to save time. So the question now for us is 55 plus, you have a higher speed for switching. Can we use that as a new solution for routine mycotoxin testing. So for all of these, they have a nice paper. This is from Aflatoxin from Austria. And this customer also provide us the standard to do this test. Okay, so the sample what we used in this case is about 500 standard mycotoxins, mastered mycotoxin metabolites, total 500 standards. I just put an example here. You can see some, about 20 here. So total is 500 mycotoxins. And we also tested in 2 different matrices, Bailey and Crohn. The HPLC method, what we used here is, assay system is from us, SCIEX axion assay, column, phenomic kinetic, and this here is the HPLC method, and the injection volume, what we use in this case is 1 microliter. And on MS side, before we decide what is the final method, we tested with the first one positive only and the negative only method. And the third one, of course, is the positive with plus negative, that is 1 injection, combine these 2 methods. And we evaluated different switching time. If you look at the run, the HPLC run is about 20-22 minutes. You have 1 run with both positive and negative, and when you extract them separately, you can see the negative XIC and the positive XIC. Look at the switching time. Here what we test is on the very left is positive only. That means the method was only positive injection, and those 4 are positive, negative switching with different switching time. 5 milliseconds, 10, 15, 50. So this is the speed you can use for classic 55. So if you look at both intensity as also on the signal to noise, you really do not see different. That means 5 millisecond positive, negative switching could give you the similar performance with positive only. The same thing we look at in negative models, so different switching time. And this is another picture. We put this together. So if you look at Aflatoxin B1 here and Aflatoxin M1, so you see this is the first transition with 4 different switching time and second transition. So you see they do not have huge difference both. So that means with fast speed, 5 milliseconds, you do get same performance with only positive injection. And of course, next step, we also look at the quality, the accuracy and quantitation. We look at the data points. So what we did is totally about 1,000 transition, 500 something positive, 480 are negative. So if you look at the data point, so this is at 1.9 minutes, this 10 minutes, you do get enough data point to ensure your quantitative accuracy, even with about 1,000 transition. This is for the, let me see this. Oh, we forgot to change, there's something wrong. This is in the negative models. The same thing, you can see about 3 minutes, 10 minutes, you do get enough data point. And to transfer the data point to quantitative accuracy, so you see here, with 5 repeated injection, what we did, you see the percentage CV and accuracy are all very nice. The same thing for Aflatoxin M1. And some other examples, what you can see here is, this is for the different concentration, and you see the CV, and both CV and the accuracy are very nice here. And of course, for the mycotoxin analysis, the next step, what you want to know is sensitivity and ratio we discussed already before. So again, with 5 millisecond switching time, 1,000 about MRMs, positive, negative. And here's an example for Aflatoxin B1. So you see that the first 2 injections blank, and you have concentration started from 0.045 ppb. So all the samples are prepared by our customer. They provide us the sample. You can see the linearity and the sensitivity is quite nice. And like you heard before, we always look 2 transitions and look at N ratio of these 2 transitions. It has to be correct. And this is the N ratio. Here, this 2 line is the tolerance for your N ratio. Depends on regulation, you give the tolerance. That means everything measured should be in that range. Okay, the same thing for the Aflatoxin B2. The reason I pick as example B1, B2 is because B1, B2 is regulated also for baby food, as you know. And you need really sensitivity to run B1 and B2 in order to run in the baby food. Okay, here is another example. You see here you have a different concentration, but it's very clear. You have a clean blank, and you can go down to the last level that customer want to run. Okay, so of course with this method, we also tested with unknown. So this is a question before I heard about N ratio. I just put one example on regulation here in Europe. We have a different regulation for mycotoxins, for pesticides, for antibiotics. So you see here for triple quadruple instrument, the required identification criteria is very clear. You have to have 2 product lines, and the N ratio in this case is 30%. And for some classes are different, like Birgit mentioned before. If your N ratio is weak, that means your second transition is very low. You can have a little bit bigger tolerance. If your 2 ions are very close, then you only have 10 or 20%. For some of them, that generally is 30%. So that means for any unknown, you have to look at your N ratio. So this is an example what we did. So you see what the injection sequence is blank, blank, the standard with different concentration, then blank again, then 2 unknowns in Bailey and Crown matrices. Again, afterwards, we inject another blank. It should be clean, okay? So this is with the software. You heard before with Multiquant, but all of this data, what we generated, what we use is SCIEX. You may have heard about, but I do not have time to go in detail. But I will say, if you say Multiquant is the best software from SCIEX, from best, actually nothing others, but I will say SCIEX even better than Multiquant. Just if you have time in the next few days, just go to our demo suite, look at the SCIEX software. Okay, so you can see here with picture show you, okay, this unknown is quite nice, N ratio is fit. With SCIEX, you also have the possibility to look at in the results table. You see here, N ratio with green, that means it's fit. Even this is unknown, it's fit average of your standard. That means this one you can conform by N ratio. Okay, so here's another example. And I just want to give you another 2 or 3 slides to show you extended linear dynamic range. So if you remember, I showed you before at the beginning, the 2 major performance enhancement with 55 plus is speed and the linear dynamic range. For the linear dynamic range, we decided to use antibiotics. The reason is, okay, so before I show you the results, what we get. So this is the comparison between classic 55 and the new 55 plus with the improvement on linear dynamic range. with some examples with pharma compounds. But definitely you will say for the contaminants analyzed, normally you will not have isotope labeled standards. Yes, nobody have internal standard for these 500,000 compounds. So here are the examples with internal standard. So therefore you see here's area ratio. So you can have improvement here from 4 to up to 6 linear dynamic range. But how it looks like if you do not have internal standard, that's most contaminants analyzed. So we make a choice of antibiotics, because if you are doing antibiotics analysis, you know antibiotics, you have different classes, and they have different regulations. For some of them, it's forbidden. That means you need to run until very low level. And some of them is allowed, but they have some regulations. So that means when you want to run them in one injection, your instrument should have some kind of linearity. Yeah, able to let you run entire panel, entire pictures here. So what again, we got a sample from customers, different classes. For each classes, we have some antibiotics there. And in this case, we use another column and another buffer. So it's formic acid. For mycotoxins, if you run, you know normally you should use acetic acid, and 5 microliter injection. In this case, what we did is only look at the positive injection positive models. And what you can hear here, just one example, we go down to 0.01 ppb up to 100 ppb. You got quite nice linearity if you look at R here. And look at the sensitivity on this instrument, 0.01 ppb. And the left, again, is 2 blank injection. And just an example here, show you the linearity. So what we got conclusion is here, with 55 plus, you can really get high quality quantitative results. What we mean high quality is that you definitely need always look at 2 transitions and ion ratio. That is required. That is what you need to conform your quantitation. And you are able to actually, for mycotoxin, this kind of thing, it's combine 2 methods into one and save time. And with SCIEX software, it's even better and quick for you to get quantitative results. And for unknown sample, you could meet regulation. And because of the high sensitivity, you can save the time for your sample preparation. Just use dilute and shoot method. And the last point regarding linear dynamic range, you can see with or without internal standard correction is, I would say, step better than classic 5500. Okay, with this, I want to thank, of course, my colleague helped me to get all the data, and also Michael and Rudy is that they provide us the sample for this testing. Okay, thank you for staying here already over time. Thank you.